Hello, it's me again, John Allison with Arkansas Ames. I am here to work my first solution to the 2025 Released FRQ from AP Calculus exam ABBC number 4. Remember, I do these cold, and I do that so that I can kind of simulate what my students feel like when they open the exam for the first time and they see the video or they see the problem. So I want to get that feeling as best I can, and also want them to see that we all make mistakes. So you may see me make a mistake on here. I have not looked at the problem before, so I'm going to look at the problem after this document camera comes on. Oh, the document camera is coming on. It's coming on. I'm not sure why. Oh, I haven't opened the video, that's why. There we go. Okay, so I'm going to do this. The last video I did, it was shaking the camera when I moved my thing up, so I'll try something a little different here. I'll make a mark where I know when I get to there, I need to move it up so you can see more. So now you can see what I'm doing. I'm going to go back and scroll up to problem number 4. Remember, I have not looked at this before. Brand new to me. All right. Number 4 has a continuous function f defined on a closed interval from -6 to 12. Graph of f is 2 semicircles. The first one below the x-axis, second one above the x-axis, and then one line segment shown in the figure. I'm going to go ahead just so you can see this. I wouldn't do this on the exam, but so that you can see what I'm looking at here. This is going to go from -6 and down to -3. In my circle. And then to 6. Another semicircle that goes up to 3. And then a line segment from 6 to 12 that goes up to 3 also. That's the graph we're looking at. Sorry for it's not perfect. This is the function f. And we're going to let g be the function. This is number 4. We're going to let g of x be the function defined by the integral from 6 to x of f of t dt. I'm going to double check to make sure you can see everything in the video real quick. Looks like you can. So part A says find g prime of 8. Give a reason for your answer. So if this is g, then g prime of x is simply f of x. That's by the fundamental theorem. So we're looking for 8. This goes from, when we look at this, by the graph, you can see that the point 8, 1 is on the graph. And so that means that since g prime is f, g prime of 8 is f of 8, and f of 8 equals 1. So that's the reason for our answer. So B, find all values of x in the open interval, -6 to 12, at which the graph of g is a point of inflection. So we're looking for points of inflection on the interval from -6 to 12. And so that means we're looking for places where the second derivative of g changes from negative to positive or positive to negative, changes concavity. So let's find g double prime. G double prime of x is f prime of x. So that's the tangent line here. And so let's say that on this one, we can say that The graph of f is what we're looking for here, though. We have to tie this to the graph of f. And so that means that f of x changes from decreasing to increasing at x equals -3 by the graph, and from increasing to decreasing at x equals 3 from the graph, and again from decreasing to increasing at x equals 6. F prime of x is equal to 0 at x equals -3, x equals 3, and f prime of x is undefined. At x equals 6, because f of x has horizontal tangent, x equals -3 and x equals 3, and f of x has a corner at x equals 6. Therefore, inflection point of G occur at x equals -3, x equals 3, and x equals 6. All right, let me move this up now. For C, we're asked to find G of 12 and G of 0. All right, we're going to bring this down a little bit so we can see the graph. Since G of x is defined from 6, we're going to find G of 12. And at x equals 6, well, G of 12, that equals the integral from 6 to 12 of f of t dt. From 6 to 12, remember this height's 3, this height's 6, or this width's 6, so that's going to equal the area under that curve, which is going to be 1/2 times 6 times 3, which is going to equal 9. We didn't have to put that, but it's 3. 1/2 times 6 is 3. 3 times 3 is 9. G of 0, this one, we're going to go on the integral. What's this 6? Be clear about that. From 6 to 0 of f of t dt. And that's going to equal negative integral from 0 to 6 of f of t dt. And since this is a semicircle, That's 1/2 of a circle with radius 3. So that equals negative. This is going to be pi times r squared, which is going to be 3 squared, divided by 2, which equals negative 9 pi over 2. And that should be g of 12. That should be g of 0. So we have those labeled. Now, D says find the value of x at which g attains an absolute minimum on the closed interval from -6 to 12. Okay, so D. We're looking for an absolute minimum. So that means we need to know the endpoint and for an absolute minimum, or the endpoint, which is -6 and 12, and then everywhere where g prime equals 0 or is undefined. We already determined that g prime is equal to 0. Did we determine that? G prime is f of x. Everywhere f of x equals 0 or is undefined. So f of x is defined on the interval from -6 to 12. So that means that it equals 0 at 0 and at 6. And those are the 4 candidates. So we can, by the candidates test, evaluate. We're looking for the absolute minimum of g. So we can find g of -6. We can find g of 12, which we already did. We can find g of 0, which we already did. And we can find g of 6, which we can do very easily. That equals the interval from 6 to 6 of f of t dt. That integral is just 0. We already said g of 0 is negative 9 pi over 2. We already said g of 12 is 9. And now we need to do g of -6. So g of -6 is the integral from 6 to -6 of f of t dt. That equals the integral from negative integral from -6 to 6 of f of t dt, which is the negative value of the semicircle, negative area of the semicircle, which we already said is 9 pi over 2. And so that's going to be negative 9 pi over 2 plus the positive area of the semicircle, which is 9 pi over 2, which equals 0. So the absolute minimum, make sure y'all can see this. I can't tell. It's barely you can see it. So the absolute minimum of g is negative 9 pi over 2 at x equals 0. And that's question number 4 on the AB exam.